My name is Valentin Clement, and I'm working as a software engineer at the Oak Ridge National Laboratory, and I'm going to give you an update on the OpenACC support in Flang and LLVM. This work is supported by the Exascale Computing project. We named this work Clacc. The goal is to support OpenACC for Flang and LLVM. The basic design is to lower the Flang AST to a mix of OpenACC MLIR dialect with the Fortran IR dialect. The work in this project is upstream as we develop it, and you can contact me if you have any question. I'm going to give you an overview of OpenACC for those of you who are not familiar with it. It was launched in 2010 as a portable directive-based programming language model supporting C, C++, and Fortran, and targeting heterogeneous accelerator. The first implementation were focused on NVIDIA GPU, but we have since then implementations targeted to AMD GCN, multi-core CPU, and FPGA, for example. It is often compared to OpenMP, but there are slight differences between the two models. OpenACC is more descriptive, when OpenMP is more prescriptive. Many features, such as target offloading, have been ported to OpenMP. OpenACC specification is also less complex, and its latest version was released in November 2019. The roadmap of our project is shown in this slide. We began this project in late 2019, and until now we have focused on the OpenACC parser and semantic checking in Flang, as well as designing an OpenACC MLIR dialect. We have been working as well to lower the OpenACC AST to a mix of FIR and our OpenACC MLIR dialect. And finally, we have contributed to generous part of Flang and LLVM to support more than one directive-based language and share lots of common code with OpenMP. Our focus after the meeting will be on the lowering of the FIR plus OpenACC dialect and the OpenACC runtime, as well as optimization we can implement directly in MLIR. I'm going to give you a brief overview of our contribution that are upstreamed. You can today use Flang to parse and check Fortran code with OpenACC directives, as well as unparse all this code. You can see on this slide the different files in the LLVM directory that are involved for these features. We have contributed to a new TableGen backend for the directive-based languages such as OpenACC and OpenMP. These backends allow us to represent the directives and the clauses in a more structured way and to generate more powerful code that can be used in Flang, but also in Clang in the future. We have here an example on these slides of ACC parallel directive with the clauses that are allowed multiple times and the clauses that are allowed only once. The design also allows to specify required clauses and mutually exclusive clauses. Clauses can be specified for a specific version of the directives-based specification as well. We have contributed as well an OpenACC MLIR dialect that is agnostic as much as possible from Flang, and that should interoperate with other core dialects in MLIR. We have already upstreamed a couple of operations, and we are working to have a first set of operations that model the most used OpenACC constructs, and we are currently working on to lower them to have an executable OpenACC program. As you can see on these slides, you have an OpenACC parallel operation as well as an ACC loop operation that represent the corresponding construct from the specification. They play well with the SCF4 operation in this case. We plan to support FIR as well as the core dialect interoperability with the OpenACC dialect. So what you should take away is that we are building an OpenACC support for Flang and LLVM. The basic design is to translate to an OpenACC MLIR dialect. We upstream as much as possible when it's ready, and you can contact me if you have any question. Our group at ORNL is hiring, so please contact us if you're interested in what we do. Thanks.